Hi there, this is Penelope, FS3128, topic 7, class 3. We're still looking at trigonometry. Now, this idea of trigonometry links into functions, and we can talk about sine as being a trigonometrical function, and just as we did before, we can draw their graphs. And also, just as we did before, with a function, if we don't know what its graph is like, we can start off by drawing a table. So all we need to do is just use our calculators and fill in the table and start looking things up. Oops, that's not 0, that's 1. Sine of 30 is a half. Sine of 60 is 0.866, and so on. And if we filled all those in, then we can use that data to draw ourselves the appropriate curves. If we plot the sine curves, the sine numbers, then we've got a typical sine curve. If we plot the cosine numbers, we've got the typical cosine curve, which is just the sine curve moved over a little bit. Now what we need to realize here is that the sine curve doesn't just go around once, it actually goes around, it just continues. And the same with the cos curve, it doesn't just go around once. Oops, it does if you've got no space. It goes around forever. And it also doesn't just start there, it goes back the other way as well. Same as this one, goes back that way too. We could have done the same with the tangent of theta and plotted that. Again, that just doesn't start there. It goes on forever as well. Now, have a look. Previously, I mentioned about tan 90. And if you draw a dotted line down there, there is no tan 90. There's a gap in the curve. So tan of 90 is undefined. And that's because it's equal to sine 90 over cos 90, which is 1 over 0. So it's undefined. And the same at 270. What we also say is that there's an asymptote at 90 degrees and 270, which means that the curve doesn't cross that line, it just gets closer and closer and closer to that line. And again, it doesn't just start there, it carries on backwards and it carries on forwards as well. But what we've got here is that the tangent curve repeats every 180 degrees. The sine curve and the cos curve, they repeat every 360 degrees. Now, those are all very useful, but if we're looking at something that's more useful, would be looking at something like y equals sine a. 3a. So we could draw a table, we could draw 3a, etc. And then we could find sine 3a, so that would be 0, 0, that would be a half, and sine 150. Fill out our table, and then what we've got is a curve, still maximum value of 1, but what we find is that it goes around 3 times in 360 degrees. So it goes around once in 120. Oops, down a bit. And again, oops, might just change that to 240. And then again in 360. Off the edge of the page, like that. So this 3 is critical. It repeats 3 times in 360 degrees. Similarly, we could look at sine 2 theta, and what we're going to find there is that that goes round twice in 360 degrees, or it goes round once in 180. So it goes round twice in 360, or once in half of that time. So it goes around once in half of 360. This one, it goes around twice in 360. But the different thing now is this 3. And what that does is instead of making this 1, it makes that 3. So it's kind of stretched by 3. We call this number the amplitude. So we say that the amplitude for this one is 3. Similarly, this one, the amplitude is 4, and it goes around twice as fast, or it goes around twice in 360. Tricky one for the next one. The amplitude's fine. The amplitude is 2. It goes up to 2 and down to -2. So it's stretched, if you like, by 2 units, and it goes around 3/5 as fast. So that means it goes round once in 360 divided by that 3/5, which is 600 degrees, which is why you can see there it's gone around once in 360 degrees. We could also look at what happens when we've got a shift. This gives us a shift. We could draw up the table just as we did before. We could have A, and we could have A minus 60, and then we could find A minus 60. We could find the sine of that. But once you've done a few, you'll see this. Let's dot in the original sine curve, like that. Now, what we find is that sine of A minus 60 actually starts, it's 90, 60 degrees later. So it's going to start here, and it's going to go through, so that one went through 180, and this is 270. So it's going to come down here at 270 minus 60, so it's going to come down here at 210. And then it's going to go up again at, it's going to surface at not 360, but 360 plus 60, which would be 420. And what we find is that each point has moved 60 degrees to the right. So that that distance is 60 degrees. This distance, not very good graph, is 60 degrees, and so on. This distance is 60 degrees. Every point has moved over, so the whole graph has just moved over 60 degrees. Similarly, we could do the same for a cos curve, and in this case we've added, so it starts earlier. So we've got our cos curve, we're just going to dot it in like that. That's going to cross at 90 and 270. This is 180. That's 1. So the whole curve is going to move 45 degrees to the left. So that's about that distance about there. So the curve is going to move like that. So this one will be over here. This one will be over here. And so on. So each point moves 45 degrees to the left. Now we could put those together and have a more complicated one. Let's have a look. The amplitude is 5, The speed, well, there's no number in front of the A. There's no number in there. So the speed is normal. But it's also got a shift. So it's going to the left. It's going to start 30 degrees earlier. So instead of going up to 1, it's going to go up to 5. Let's just dot in ordinary sine. So that's 180, that's 90, that's 270. So it's going to start to the left. So every point is going to move over 30. So that would be 60. This point would be moved over 30, it'd be 150. This point would be moved over 30. This is 360. It would be moved over 30. There we are. This is sine 5 sine A plus 30 degrees.